My name's George Willis. I'm a PhD student at the University of Birmingham. My research especially focuses on urban shrinkage in China, and particularly through urban networking and spatial analysis. So this paper is on detecting the urban structure through the intercity patterns through human interactions. So some background. As we all know, China is experiencing unprecedented levels of urbanization, particularly in the last 3 decades. However, while there are some global cities such as Shanghai or Shenzhen growing rapidly, there are also cities that are contrasting with a much bleaker picture, which are far smaller in China and are often forgotten or left out of research. So this research aims to look at all of China as an urban network, and rather than removing these smaller cities from analysis, often we're going to focus on them. So they often lie in the shadow of global cities, right on the periphery of networks or disconnected entirely. They struggle to generate capital or flows of goods and services from the larger cities in the network due to geographical isolation or just having a lack of transport flows or any reason like that. And looking at from a shrinking cities point of view, a large cause of shrinking cities or symptom of shrinking cities is often outward migration. So combining that with, one way to look at this sort of thing is by looking at where are people moving in and around China. So this study utilizes human mobility patterns to study these spatial patterns of where people are going, where people are coming into, and which cities are more popular and important within the wider network, and which ones suffer as a result. And then once we do that, we aim to create a typology of Chinese cities. So we create network measures to provide characteristics of each city within the network. And then once we do that, in order to simplify the complex cities, we simplify it into clusters of cities that share similar characteristics in order to aim policy planning and just see why these cities share characteristics and how they operate. So to do this, we use the Baidu seasonal flows. Baidu is similar to Google over here. It's the second largest location-based data provider in China. This data particularly uses mobile devices, so phones, tablets, laptops, anything connected to Baidu Maps. It has around 400 million users, and Baidu use it to create georeference data sets in China. And our particular data set is a user's device intercity connections at the prefecture level. So there's 342, I think, around 340 prefectures in China and prefecture cities. And these provide origin destination data of how many people are moving from one to the other. Where this data is unique is that rather than just extracting a user's origin and destination and taking that as the flow, this is more long-term in that a device would have to originate and then move to the destination and stay in the destination city for 3 months for it to count as a flow. So this means that rather than just capturing your regular commuting patterns or weekend trips and things like that, it's more midterm to long-term migration activities. Whereas, previous researchers looked at commuters or even predicting population based on transport timetables. This is actually people's movements from one city to another. So that's the unique of the data. And this is just an overview of what the data sort of looks like, just to get an idea. As expected, it's heavily concentrated in the major cities, Beijing, Shanghai, and the Pearl River Delta at the bottom. This is just the top 10% of the flows in spring of 2017. So this is people that left in March and stayed until June, in 2017. And this is the data that we're working with. So to work out a city's role within the network, we're adopting a network approach. this sort of approach is extremely useful, particularly for this type of data. In our case, the cities are the nodes, and they're connected by the flows of people. We use this to understand a city's roles within the network. So rather than just looking at which city has the most flows, which is obviously important, but fairly simple, we're also looking at what the role is within the network. So is a certain city receiving far more flows than they're outflowing? So why would that be important? Are they connected within a mega region or polycentric area? So the impact of being neighboring to a major city, how does that affect it? So that's why we have adopted a network approach. And to do that, we use 6 measures. Degree is fairly straightforward. It's just the number of cities that one city connects to. So if a city A has a flow to city B and C, that would be a degree of 2. Strength then weights these links. So in that example, if there was 100 people going from city A to city B, and then 100 people going from city A to city C, the strength would be 200 because that's the weighted link. PageRank is it's a measure of importance of a node. It's based on Google's web pages algorithm, and each node in the network is assigned a score, and it's based on its number of links it receives, but also it takes into account, because it's an iterative algorithm, it takes into account where these links are coming from, and if they're coming from a more dominant city within the network, they'll have a higher rating. So we use that to see the importance of a city within the network. Then we have node symmetry. Node symmetry is a fairly simple equation just to calculate the whether a city has more inflowing or outflowing flows over our time scale. So it just it's between -1 and 1. -1 being it only has people leaving the city and nobody coming in, and 1 being everyone is coming in and no one's leaving. And so by minusing the inflowing and outflowing people, you get a number between -1 and 1. And that's, again, to just give us an idea of the city's role within the network, or what type of city it is. And finally, we have the hubs and authority scores. This is a symbiotic relationship, really. A city with fewer flows, a city with a lot of flows will be an authoritative city. It will have so it will have a high authoritative score, but then a city that's connected to an authority city will have a higher hub score due to being connected, and therefore the authority score will be higher, and it's sort of a symbiotic relationship. But again, this is really useful to measure the mega regions and polycentric areas of China, or cities that are really densely concentrated together. So that's why we use those measures. And this is just a quick overview of the measures once we've calculated. So there are 342, you can see in the out degree, there are 342 cities in our data set, and at least one of those cities was connected to all of them with a max out degree of 342. I won't go into this too much detail because we don't have too much time, but from just the mean out degree is 214, which suggests that on average, a city is connected to almost 2/3 of the cities. So it's a very densely connected network. So yeah, that's worth bearing in mind. But there are some cities that can only connect to 18. So there are some really on the periphery there. Just some basic plots of these. We have the degree density on the left there. As expected, there are some cities that completely dominate the network, heavily weighted by, so they completely dominate the whole network, and those are your major global cities that we talked about at the beginning. But there are also some much further down that have next to no flows or any degree at all. And even if they do have some connections, there's very few people that are moving out. And then on the right, we can see the use of the authority and hub scores. So while we have some similar cities such as Shenzhen, Shenzhen and Beijing, they're still there. But Foshan City, for example, is located in the Pearl River Delta, and therefore by being very close to other global cities such as Guangzhou in that region, that sort of cities bumped up a lot more due to its neighboring cities. So once we have our network attributes for each city, we want to be able to condense these into categories of typologies of cities, and just to help researchers understand the type of cities that are there in China. And rather than having 342 varying cities, it just makes it simpler to understand. So we utilize k-means clustering for this. We established, after some basic tests such as elbow method and silhouette, we established that 7 was the optimum number of clusters. And then it goes through an iterative process of assigning each data point to a cluster until it has the optimum sum of squares. And that the results look like this. So immediately there are lots of there are NAs, and that's due to later in this presentation we're going to be looking at traditional node data. So that is like socio-demographic data, and we didn't have the right data for all of the prefectures. So we have 290 of them out of the 342. So the gray ones are ones that we did not include in our k-means, just because we couldn't use it later on in the research. But as you can see, so we have the blue is our peripheral isolated category there. We have the major cities are in pink, so the Beijing and Shanghai. What you may not be able to see is category number 3 is exclusively the Pearl River Delta. It's right down here. And there are just 3 cities there that have their own cluster due to high authority and hub scores, I imagine. And so they managed to create their own cluster based off the data. And Harbin as well is a regional dominant city there. So it's quite a high population city, but it's not located near too many major cities, but it's made its own category there. So to summarize that, at their average scores, we can look at the number of clusters, number in each cluster, sorry, and what we've sort of called them, each typology. So number 1, cities that were quite centrally located, but they weren't very well integrated in the network. So they have quite a low strength, out degree, page rank. They have low values across the board, but they're quite centrally located. So you would expect them to do a bit better than they do. We have the Pearl River Delta, as I discussed. It's just 3 cities in that region that have extremely high hub and authority scores and strengths, particularly people moving between them. And then number 4 was regional dominant cities. That was an example. There was Harbin in the northeast. If we go back, so up here we have Harbin and other examples around here. They're cities that are big enough. They're big enough to have a lot of flows on their own, but they're not necessarily near other major large cities. And then we have the peripheral cities that was cluster 5. The lowest across the board, pretty much. So they have very low strength. They're not connected to many cities, low page rank. And so they're very isolated cities right in the periphery of the network. And then number 9 is our mega cities, which are the Beijing and Shanghai, that weren't included in the Pearl River Delta, but they're our major cities. And this is just a comparison of the flows. So this is comparing the peripheral cluster that we have to the megacity cluster. And what's here to notice is just how regional or nearby the cluster 5 flows stay. They don't venture too far, whereas the cluster 7, they're attracting flows and attracting flows from across the whole of the country, as you would expect, and they're connected to pretty much every area in China. So it's just a demonstration of how the difference in connectivity really. So the next step really is to compare these clusters that we've made based on purely network attributes to traditional socio-demographic data. So to see what the characteristics are of these cities. Are they high in population? Are they struggling financially and things like that? So to do this, we compare it to we use the census from 2000, 2010 and 2017 statistical yearbook to get the population data, and all the rest is taken from 2017 yearbook. So we use the population, the GDP, and population difference, and long-term population difference. And then to use this data, we adopt a multinomial regression model where the clusters are a dependent variable, and we use these listed data there to predict what category they would go in based on these data. So our baseline category is cluster 2, and that will make more sense when I go to our results. So by saying this, if we take total population for an example, if we just look at the significant results, we say that by increasing population, it would be less likely to be in the weak but close cluster, and it would be a lot less likely to be in a peripheral cluster, suggesting that these two have a typically low population count, whereas the megacities, of course, have a high population count. Population difference, the only significant one is the peripheral cities. So this suggests not only do they have a low population, but it's also shrinking over time. So they'll have more people are perhaps moving out, an aging population, or and there's a number of theories behind why cities shrink. The weighted flows. So if you increase the weighted flows by 1, you have more chance of being in this cluster. And that therefore means that not only are these megacities having high populations, which would encourage higher flows, but also the flows per person are far higher than any other category. So that's expected. And finally, as I've not got too long left, if we look at primary GDP, so the positive, if you increase primary GDP, you have more chance to be in peripheral or the weaker categories. So these are cities that focus on mining or logging and things like that. And this is often the Rust Belt of China. So cities that are on the periphery, as China integrates itself more in a global market, the use for industrial, the demand for industrial industries declines, and this is often one reason why people leave and these cities start to shrink. So so we do see some of the theory behind that in our results here. And so, yeah, just to close, we used human mobility data to look at the Chinese network, and we established the 7 clusters, and we then look at what characterizes these clusters and how they're formed. And I'll leave it there. Thank you.
First of all, we've got great study. I agree. I enjoy this session. Is there any reason why you chose China for your study? Is it because of mobility data availability? And could a similar study be conducted in other countries?
Yeah, you're correct. That is the reason why I chose it. The data was made available to us, so I formed the research based around the data. And there's currently a lot, but also I focused on shrinking cities, and there's a lot of research going on in China now about shrinking cities, which was where my approach came from. So there's a diverse range of cities in China, so that's the primary reason why we chose it, but also data availability as well. But I'm sure if you can get similar sort of flow data with actual human mobility, I'm sure you could conduct a similar approach in different countries.
From Patrick says, great talk, George. Do you have your code detailed methods available anywhere? I know a lot of my peers up in Liverpool who will be very interested in this approach.
Oh, thank you. Well, I can certainly make my code available. The data can't be, but I can certainly, if you want to contact me personally, I can share some of the code that I used. It was all through, I've done all of it through R. So yeah, I'm happy to go through some of that. Yeah, happily share, but I haven't got it open anywhere at the moment purely because of the data privacy, but the code itself, I'd happily be interested in sharing.
I've got a question from myself,
Yeah.
if I may. How do you think like your categories and your classifications could be used for intervention strategies? And is there a need within like the literature that's been expressed for intervention?
Yeah, so it's the particular use is identifying the two groups that I find most interesting, and are the ones that are isolated, particularly in the peripheral regions, and then it will be going into more detail about, is it due to transport links or geographical isolation, or is there simply just nobody wanting to move to these places, or that's one example. But also looking at the second category was the cities that were very close to major cities but still not getting involved in the network, or having a lot fewer flows, the causes behind that. And it would require a little bit more research, but that's sort of to group those sort of cities together, you have an idea of what the shared characteristics are of these cities, and then it's building from there, really.